The ball didn't move forward and over the net until an outside force acting on the ball, which is the man hitting the ball. This force caused an acceleration in the ball's motion. Since the volleyball isn't heavy, it doesn't have much mass or inertia, therefore it isn't too hard to get it moving and accelerate over the net.
Here, the soccer ball remains at rest until an outside force, the man's foot, acts on the soccer ball. Then the ball keeps moving until the man stops it with his foot. Although friction is also acting on the soccer ball in this case, it could be neglected.
Forces cause acceleration, and the more mass or inertia an object has, the harder it will be for it to move. Since a volleyball doesn't have a lot of mass, it doesn't have a lot of inertia. Therefore, the greater force you apply to the volleyball, the farther and faster it would move. Rather, if you don't apply effort when hitting a volleyball, it wouldn't move very fast or far.
When a hand hits a volleyball, the hand applies a force on the volleyball, and the volleyball returns the same amount of force to the hand with an equal but opposite force. This creates an action-reaction pair.
While the person is running, they increase their horizontal component of motion. As he travels in the x direction, the person accelerates. As the person jumps, they gain momentum and jump higher. The vertical component increases, making them go further into the sandpit. The faster you are while running, the further you will move horizontally.
There is less friction in the ice skating rink due to the ice. Giving a small slide will give less friction, but if you give a big slide, that will provide you more friction than your past attempt. Since there is less friction in the ice skating rink because of its smooth surface, there will also be less amount of mu. Force of friction depends on the amount of mu and normal force. Therefore, since there's less mu, the force of friction will also be smaller.
The law of conservation of energy states that energy is never gained or lost, but only transformed or changed. As the ball starts moving from the impact of the hand, it has kinetic energy because it has a lot of speed. It has a larger kinetic energy and some potential energy, but not too much. As the ball keeps going up and reaches its maximum height, its potential energy increases and its kinetic energy decreases. As the ball goes over the net, it's starting to lose height and its potential energy decreases while its kinetic energy increases. Throughout the ball's trajectory, the mechanical energy doesn't change and stays the same throughout.